In this lesson, we're going to be using the exponent laws to simplify expressions. Now recall that if we have a base a that's raised to the exponent n, that just means that our base a is multiplied by itself n times. Here's a list of all of our exponent laws, and you should have at least learned some or maybe even all of them before. In our multiplication rule, we have two terms with the same base that are being multiplied. A to the power of m multiplied by a to the power of n. What we can do is we can add those exponents because they have the same base a. So that simplifies to a to the power of m plus n. And in our division rule, if we have two terms with the same base that are being divided, a to the power of m divided by a to the power of n, that can be simplified to a to the power of m minus n. In the power of a power rule, we have a to the power of m, that's all raised to the power of n. And that just simplifies to a to the power of m times n. So we would multiply these two exponents. In the power of a product rule, we can have two or more terms in brackets that's all raised to the power of m. This just means that that exponent m applies to everything in the brackets. So in this case, we'll have a to the power of m times b to the power of m. This is similar to our power of a quotient rule. So in brackets, if we have something that's being divided, a term that's being divided by another term, and we have an exponent outside of those brackets, then that means that exponent applies to everything inside that bracket again. So we would have a to the power of m divided by b to the power of m. And our zero exponent rule says that when we have anything to the power of 0, that is always equal to 1, as long as our base is not equal to 0. And lastly, when we have negative exponents, we can rewrite this with a positive exponent. So if we have base a to the power of negative m is our exponent, we can rewrite this as the reciprocal. So we would rewrite this as 1 over a to the power of m with a positive exponent. And our base a cannot be equal to 0. In this first example, we need to simplify and write as a single power. So that means we need to have one base here. In the first one, we have x to the power of 6 times x to the power of 4 times x. Now this last x here has a power of 1. Since these all have the same base of x, we can just add exponents. So this just becomes x to the power of 6 plus 4 plus 1, which is just x to the power of 11. In this next one, we have x to the power of 24 multiplied by x to the power of 9. So these two things here are being multiplied by each other, and they do have the same base. So that means we can just add the two exponents. So this will just become x to the power of 24 plus 9, which is just x to the power of 33. In the next one, we have xy to the power of 5. Now this 5 applies to everything in the brackets, and I know this because it's right outside of those brackets. Xy cannot be multiplied any further, so this just simplifies to x to the power of 5 times y to the power of 5. And then we have x to the power of 2, all raised to the power of 3. Now since this exponent of 3 is right outside these brackets here, it still applies to everything that's inside the brackets. So in this case, we are multiplying our two exponents. So this just becomes x to the power of 2 times 3, which is just x to the power of 6. And now I want you to pause the video and try these 3 questions on your own. Come back to the video when you're ready to check the answer. In part E, we have x to the power of 14 multiplied by x to the power of 11. So we do have the same base x, and we can add our exponents. So this is just going to become x to the power of 25. In part F, we have m to the power of 10 multiplied by m to the power of negative 4. Now we do have this negative exponent. Some of you may have tried to change that into a positive exponent and then simplified it from there, and that's totally fine. You would still get the same answer. But I'm just going to use our multiplication rule because these have the same base, so we can just add our exponents. So our exponents would be 10 plus negative 4, and that just gives us m to the power of 6. And then our last one, we have m to the power of negative 4 times n to the power of negative 3, and that's all raised to the power of negative 2. And I'm going to ignore the negative exponents for now. I'm going to use our power of a power rule because in our brackets you can't simplify that any further. But this power on the outside, that exponent of negative 2, applies to everything inside the brackets. So that just means m to the power of negative 4 is raised to that power of negative 2. And n to the power of negative 3 is also raised to that power of negative 2. So we need to multiply exponents here. So negative 4 times negative 2 is just a positive 8. And negative 3 times negative 2 is a positive 6. So our final answer is m to the power of 8 times n to the power of 6. There are some things to note when you have a negative base. So if we have negative 3 to the power of 2 and that base, negative 3, is in brackets, that means that 2 also applies to the negative. The power applies to the negative. So this is just negative 3 times itself, times negative 3. And negative 3 times negative 3 is a positive 9. But if we have negative 3 to the power of 2 and that base is not in brackets, that means that power of 2 only applies to that 3. So that negative is going to stay out front, and this is just 3 times 3. So keeping that negative out front, our answer is negative 9. What about when we have negative 3 to the power of 3, and that base negative 3 is in brackets? Well, this just means negative 3 times negative 3 times negative 3. So negative 3 times negative 3 is a positive 9, but 9 times negative 3 is negative 27. But then if we have negative 3 to the power of 3, there's no brackets around our base. We're going to keep that negative out at front, and we have 3 times 3 times 3. This is just going to be negative 27 as well. So let's compare these. If you have an exponent of 2 or your exponent is an even number and your base is a negative number that's in brackets, your final answer is going to be positive. But if your exponent is 3 or any odd number and your base is a negative number in brackets, your final answer will be negative. But if you have a negative number to the power of anything, whether it's an odd number or an even number, but that base is not in brackets, that means that that exponent does not apply to that negative. So your final answer is going to be a negative number anyways. In our next example, we're going to evaluate these. So we have 4 to the power of 3, and this is just 4 times 4 times 4, which is equal to 64. Then our next one, we have negative 3 in brackets to the power of 5. So that means that power applies to that negative. So this is just negative 3 times itself 5 times. You don't have to write this whole part, but this is equal to negative 243. So we do have a power that's an odd number, so our final answer is going to be negative. In the next one, we have 2 over 3 to the power of 3. Since this is in brackets, that exponent applies to both the numerator and the denominator. So this is just equal to 2 to the power of 3 over 3 to the power of 3, which is just 8 over 27. And in our last one, we have 4 to the power of 1 plus 4 to the power of 2. Well, we know that 4 to the power of 1 is just 4, and 4 to the power of 2 is 16. So this is equal to 20. In the next one, we're working with some variables, and we need to leave our answer with positive exponents only. So we have 5x squared to the power of 2, and this power applies to everything inside those brackets. So we can rewrite this as 5 to the power of 2 times x squared to the power of 2. And 5 squared is 25. X squared to the power of 2, in this case, we need to multiply our two exponents, so this is just going to become x to the power of 4. And that cannot be simplified any further, so that one's done. Now I want you to try the next one on your own. And here's my answer. So this exponent of 3 applies to everything inside this brackets. So we have 3 cubed times a cubed to the power of 3 times b to the power of 4 all to the power of 3. So 3 cubed is 9, and this is just a power of a power, so we need to multiply our exponents. So we have a to the power of 9 times b to the power of 12. Here's our next one. In the numerator, we have 2x squared to the power of 3. So that exponent, 3, applies to everything in the brackets. So this is just 2 to the power of 3 times x squared to the power of 3. And in our denominator, we have 2x squared. So that squared applies to everything in the brackets. So this is just 2 squared times x squared. I'm going to keep this as 2 to the power of 3. X squared to the power of 3 is just x to the power of 6. And in our denominator, I'm going to keep this 2 to the power of 2. And x squared can't be simplified any further. And I kept this like this so we can practice using our quotient rule, because we have the same base of 2 in both the numerator and denominator and the same base of x. So that means we can subtract our exponents. So we can do 3 minus 2 and 6 minus 2. So looking at our base of 2, when we do 3 minus 2, we're just going to get 2 to the power of 1, and we don't need to write that exponent of 1. And then when we do 6 minus 2, we're going to get x to the power of 4. Here's our next one. So we can't actually simplify anything in our numerator further, so we're going to keep that exactly the same, a to the power of m times b to the power of 3. But in our denominator, we have this exponent of 2 on the outside of these brackets, so that exponent applies to everything on the inside of the brackets. So that means this is 3 squared times a squared times b to the power of n all squared. And we can continue simplifying the denominator, so the numerator stays the exact same. And in the denominator, 3 squared is 9, a squared will stay the same, b to the power of n squared would just be b to the power of 2n. And we can continue to simplify this. So if we look at both the numerator and denominator, there are some things that are in common. There's an a and a b in both the numerator and the denominator. And the only thing we can do is use our quotient rule, so we could subtract our exponents. So looking at our a, we can subtract m and 2. So this would just become a to the power of m minus 2. And looking at our b, we could do the same thing and subtract. So it would just be b to the power of 3 minus 2n. And that's our numerator, and in the denominator, we still have this 9. And that's our final answer. Here's the next question, and we can start applying those exponents on the outside of the brackets to everything on the inside. So this will just become 3 to the power of negative 3 and a squared to the power of negative 3. And in our denominator, we have 2 squared times a squared. And let's continue by getting rid of those brackets in the numerator, so we can just multiply those exponents. So this will become 3 to the power of negative 3, I'm going to keep that the same, a to the power of negative 6, and that's over 2 to the power of 2 times a to the power of 2. And we do have something common in the numerator and denominator. There's a base of a, so we can subtract our exponents. So I'm still going to keep this 3 to the power of negative 3 in the numerator for now. And when we subtract these exponents, negative 6 minus 2, we're going to get a to the power of negative 8. And that's over 2 to the power of 2. Well, 2 to the power of 2 is just 4. And looking at what we have left in the numerator, we have 2 negative exponents. So we got to bring that down to the denominator, because to get rid of the negative exponent, we need to rewrite these as the reciprocal. So in the numerator, we're just going to be left with 1, and in the denominator, we're going to have 3 to the power of 3 times 4, and we'll bring that a down as well. This will just be a to the power of a positive 8. And our final step is to do this 3 to the power of 3, which is 27, times 4, which is 108. So our final answer is 1 over 108, a to the power of 8. For our next example, we need to leave these in the lowest fraction form, no decimals, so don't put these in your calculator. So pause the video and try them on your own. Here are my solutions, and you may have solved these in a different way, but you would still get the same final answer. In the first one, we have 5 to the power of negative 2, so we have a negative exponent. So I rewrote that as the reciprocal with a positive exponent, and that's just 1 to the power of 25. And in the second one, we also have a negative exponent, so I rewrote that again as the reciprocal with a positive exponent of 4. So that is equal to 1 over 81. And in the next one, I just rewrote this as a fraction. So we have 15 to the power of 19 divided by 15 to the power of 20. And since we have the same base, we can subtract our exponents. So 19 minus 20 is just a negative 1. And rewriting 15 to the power of negative 1 with a positive exponent, you'll just get 1 over 15. In our next example, we have 5 over 6, all to the power of negative 2. And if you rewrote this as the reciprocal, 1 over 5 over 6 is the reciprocal. And this is the same thing as 1 multiplied by 6 over 5, which is just 6 over 5. So this is the reciprocal. So we can rewrite this as 6 over 5 to the power of 2, a positive exponent. And that 2 applies to both the numerator and denominator. So this is 6 to the power of 2 over 5 to the power of 2, which is just 36 over 25, and that cannot be simplified any further. And now you can pause the video and try these two questions on your own. So here are my solutions, and again, you may have taken a different route than me, but you should get the same final answer. So in my first one, I flipped this. I took the reciprocal, and it now has a positive exponent. And I apply that exponent to both the numerator and denominator, so negative 3 cubed is negative 27, and 1 cubed is 1, so this is just negative 27. And in my next one, I found that there is a common base between the numerator and denominator, so I simplified that right away by subtracting the exponents. You would get 2 to the power of 1 to the power of negative 2. And we would just multiply these exponents, so this is just the same thing as 2 to the power of negative 2. And here I rewrote that with a positive exponent, so I took the reciprocal, and now it's 1 over 2 squared, and that's just equal to 1 over 4. So here's our next question. We have 1 over 4 to the power of 0 plus 1 over 5 to the power of negative 2. So let's do this in two parts. 1 over 4 to the power of 0, well, what's anything to the power of 0? Anything to the power of 0 is just 1. And we can do 1 over 5 to the power of negative 2. Well, we can turn this into a positive exponent by using the reciprocal. So this will just become 5 over 1 to the power of a positive 2. And we need to apply that exponent to both numerator and denominator. And we're just going to get 25 in the numerator and 1 in the denominator. So when we combine these together, 1 plus 25 over 1 is just going to be 26. And here's our next question. So we have these two things in the brackets that are being subtracted. So we cannot apply this negative 2, this exponent of negative 2 on the outside and multiply it by these two exponents on the inside. We cannot do that here. we need to deal with everything on the inside of the brackets first, simplify these as much as possible, and then use our exponent on the outside of the brackets. So on the inside of the brackets, if I wanted to rewrite 2 to the power of negative 1 with a positive exponent, that would just be 1 over 2. And then rewriting this thing with a positive exponent, this would be minus 1 over 2 to the power of 3. And remember, these are in brackets because it's all to the power of negative 2. So inside the brackets, we have 1 over 2 minus 1 over 2 to the power of 3, and that is just 8. And that's all to the power of negative 2. And I need to subtract these two fractions in the brackets here. So I need to have the same denominator. So we can multiply this whole first fraction, 1 over 2, by 4. So I get a denominator of 8. So that's going to be 4 over 8 minus 1 over 8. I'm going to put that in brackets because that's all to the power of negative 2. And 4 over 8 minus 1 over 8 is just 3 over 8 to the power of negative 2. Now we need to rewrite that with a positive exponent. So we're using the reciprocal 8 over 3 to the power of 2. That 2 applies to both numerator and denominator. So this is equal to 8 to the power of 2 over 3 to the power of 2, which is just equal to 64 over 9.